Ladies and gentlemen, I must admit that is one of the coolest intros to any video lesson I've ever done. You got it. Whether you're a Star Wars fan or not, that is amazing. Here is your essential question for Section 8 of Chapter 9. How do you use the Pythagorean theorem in space figures? That is correct. Oh, by the way, we're going to be talking a lot about three-dimensional figures in this section. Actually, two specific ones. One called a rectangular solid and one called a regular square pyramid, which you'll see. However, in Chapter 11, when we get to that, we're going to tremendously talk about three-dimensional shapes, all kinds of different ones. So my suggestion, ladies and gentlemen, if you're looking to do anything cool like I am, you better get out your handy-dandy pocket 3D dimensional 3D glasses. I'm going to put these bad boys on so I can get the full effect this entire video. If you got a pair, pause the video, go get them. If you don't, pick them up wherever you can pick them up. Let's go into the video. Here's the first thing we're going to talk about, something called a rectangular solid. What is it? A rectangular solid, a quick example is this. A tissue box. Sorry, my face is that was in the way. A tissue box. That is a rectangular solid. A box of that paper was in, like copy paper from the school. There you go. That is a wonderful rectangular solid. Here is one as well. It's a rectangular solid. Wonderful. Here is another type of rectangular solid, of which you saw both of these fly across the screen in that intro. That's a rectangular solid. That's a special kind of rectangular solid. Now you might be asking this question, I would if I was you. How in the world do we actually draw a rectangular solid like this in a two-dimensional space? Here's how you do it. Draw a rectangle first, and then somewhat to the upper right of that, draw in a congruent rectangle to the one that you drew at the beginning, and then all you have to do is connect your vertices. So connect that vertex to that vertex, these two vertices, and the last ones. And ladies and gentlemen, ba-bing, you've got your rectangular solid. Congratulations. That is awesome. Now, we need to talk about a couple definitional words that you're going to see a lot about a rectangular solid. So you need to label all the vertices like this, A, B, C, D, E, F, G, H. Oh, it's in alphabetic order. How cute. In every rectangular solid, they have things called faces. And the faces are nothing more than this. They're just rectangles. And if you counted all the faces, they are the actual things like this. The faces, like here's a face. Sorry, I didn't actually realize this. There's a face right there. I know you don't believe me. This is really awkward. I'm not pausing the video. This is too cool. So here's an actual face. This is the face of the rectangular solid. This is a face. This is a face. The bottom's a face. This side's a face. It has faces that are all rectangles. How many are there if you counted them? You're right. There will be a total of 6. So those are the faces, all rectangles. Now, here's a scoop. In a rectangular solid in which it is a cube, every single face happens to be what kind of a shape? Not quite a rectangle, be more specific. They're actually all squares. Every one of these are all squares. So in a rectangular solid that happens to be a cube, all 6 faces are congruent. All 6 of these guys, everything's congruent in a cube. That's one distinction that you need to remember when we get to questions about cubes. Regardless, in every rectangular solid, whether it's a cube or a solid, you got things called edges. They are just simply from vertex to vertex. They're just segments that goes from A to B, or B to C, or C to D. How many are there? There's 12 of them total. But here's what's cool. They do all form right angles. I don't care where it is. If it's here, that's a right angle. If it's here, down here in the middle, that's a right angle. If it's back here in the back corner, that's a right angle. If that's a right angle. Here's a right angle. Whoa, that's ugly. But you get the idea. Let me fix that. That's not really fixed, but that's a right angle. That's a right angle. Down here's a right angle. They're all right angles everywhere. That's extremely important when we get to some questions about these things, rectangular solids and or cubes. Okay? What else is there in a rectangular solid? Well, you got these things called diagonals. Now, in a rectangular solid, the diagonal is this. I'll show you one on the video first, and then I'll show you a live one. Well, it's not a live, but you get the idea. So from G, this point, I'm going to draw a segment that goes through the middle of the solid way over here to A. And I know it's tough for you guys to say. You don't got the actual glasses on. I got it. But that is a diagonal. Now, if I take the lid of this thing off, bye-bye face. If I take this off, you can kind of see, let me move this. You can kind of see in here there's a string. And if you listen really closely, I can play it. Listen. Boom, 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 boom. Did you hear that? It's pretty cool. That is my my bass, I don't know what you call it, my rectangular solid guitar. It's awesome, dude. You can make them yourself too. Just get a piece of string and a box, and you got it. Regardless, here is your diagonal. It goes from one vertex through the center to the other vertex. Now, if I ask you the question, is it a segment? You'd say yes, and I agree with you. It is a segment. What else would you say about it? Well, how many are there? How many? There would be 4. There are 4 total diagonals. Now, here's the thing I need to tell you about diagonals. In a solid, there's something called a diagonal of a solid, which I've already described to you. It's A to G. But there's also a thing called a face diagonal. And a face diagonal is a diagonal of the rectangle that is one of the faces. So if I just take the bottom of this rectangular solid and I draw a diagonal that goes across like that, that's not a diagonal of the solid, guys. That is a diagonal of the face. It's a face diagonal. However, check this out. If I take the face diagonal, and I take this one I'm drawing, which is a diagonal of the solid, and I connect the edge back here in the back, what does that create? You betcha. It creates a sliver of a right triangle out of the middle of this rectangular solid. And I promise you that's going to be used a lot in some questions here. Now, I'm not saying, hey, is this a 30, 60, 90 triangle? I have no idea. We don't know that, but we at least know it's a right triangle. So that's a pretty cool thing. So there's your rectangular solid in terms of a three-dimensional space. So what else do we got? Well, we got this thing called a regular square pyramid. Here it is. Looks just like that right there. So it is a solid. 3D glasses help me see it tremendously. Plus it's right in front of me. But this is a rectangle or a regular square pyramid. How do I draw this thing? Well, key thing is this. You do see the base here, and it says the word up here, square. It is a square base. This thing here is the base. It's the bottom of it, or whatever. That thing right there is the base. It's a square. In Chapter 11, guys, we're going to talk about things that are hexagonal pyramids, pentagonal pyramids, triangular pyramids, but in just this section, we're only doing squares. Okay? Remember that. How do I draw this thing, though? Well, you can't start with a square. Actually, what you have to do is start with a parallelogram like this. I know it seems weird, but that's what you have to do. So start with a parallelogram, and you have to slant it more than what you really think. So slant that thing over, and put a little dot right here in the middle. Right here somewhere in the middle of that parallelogram. Couldn't think of the word. And directly up, I mean perpendicularly up from it. Like, I mean right up here somewhere. Not over here to the right, perpendicularly up from it. What you need to do is draw a point. Whoops, sorry. Let me go back. Can I go back? Here we go. So, there you go. So, straight up from that dot that I had before, straight up from it, draw another dot. And all you have to do is this. From that dot, just simply connect all 4 vertices of the base, like such, and watch it go. What you're creating, guys, is your first regular square pyramid. Congratulations. Now, my suggestion, redraw it a second or third time, because most likely the first one you just drew isn't that nice. Redo it. I know, they take a little bit to get. However, when you do finally get one you like, here's how you got to label it. Label the top point A, and then the base vertices B, E, D, and C. And in every square pyramid, you got these 2 things exactly like a rectangular solid. Faces and edges. The only difference is the actual faces of a square pyramid, or any pyramid, they're all triangles, which of course you know, but that is a difference. Edges are just the same. They're all the edges no matter what they are, from vertex to vertex. So here's a couple new things, and I already talked about this a little bit, the base. This thing here is the base. That is a square pyramid, or a square pyramid, so the base is square. Very important, by the way, that we know that. However, here's something maybe kind of new, the word vertex. What is the vertex of a pyramid? It's this, and this is what I'd write down if I were you. The vertex of a pyramid is where the edges all meet at the top. That point up there is called the vertex. So if you need the video, or if you need that definition, pause it, go back to it, and rewrite it. What else is there in a square pyramid? Something called an altitude. Now you guys know this. An altitude we've seen many times. We've seen an altitude in a triangle. We've seen an altitude in all kinds of different quadrilaterals. We've seen them in trapezoids recently. What is an altitude? Well, it is a segment that comes from a vertex somewhere and goes to some other side, forming a right angle. And if you look how this works in a regular square pyramid, it starts at the vertex, goes through the center of the shape of the solid, and it goes right to the middle of the base. So my definition would be this. An altitude comes from the vertex, goes to the center of the base, and forms a right angle with the base. That is your exact definition of an altitude of a pyramid. There it is. So what's next? One more thing that goes along with regular square pyramids. It's something called slant height. And if you wanted your definition of slant height, here it is. It is a segment that comes from the vertex, and it's drawn perpendicularly to the edge of the base, and since it's an altitude, well, you don't know this really, slant height, it actually forms right angles with the edge of the base. So it's a segment, comes from a vertex, goes right down here to the midpoint of the edge of the base, forming a right angle. Now I kind of let the cat out of the bag a little bit, but here's the scoop. This slant height, you could say, is nothing more than the altitude of the face of this regular square pyramid. Whoa, go back and replay that. So the altitude of the pyramid itself goes through the center, forms a right angle. The slant height goes down from the vertex on the face, forming a right angle and going perpendicularly, like I said, to the midpoint. That's pretty cool. Last thing that you need to know about these little things, which is actually pretty cool. The altitude comes down here, the slant height comes down here. And the thing is, I don't care where you are in this picture, but that's a right angle like I said before. That would be a right angle over there. You could draw one back there, a right angle. You could draw one back there, a right angle. You could draw one forward right there as a right angle, right there. It's all, that was like a spider. Ooh. They're all right angles around that pole, if you will, that stick, whatever it is, of an altitude. But here's the scoop. If I connected this center of the base to the midpoint over here like that, what does it create? Ooh, lovely. It creates a nice little right triangle. Hey, Mr. Motter, that looks like a 30, 60, 90 triangle. Haha. You need these, people. Can you put these on there? Can you see that? It's not. Well, I mean, it could be. We don't know, though. Maybe it's a 45, 45, 90 triangle. Maybe it's a 3, 4, 5. Maybe it's an 8, 15, 17. Maybe it's a 9, 40, 41. We don't know. But we certainly know this. If I take this pyramid, regular square pyramid, like such, hello, like that guy right there, and I connect these guys again, it just creates a nice little right triangle. So, ladies and gentlemen, there you go. Congratulations. Welcome. Well, we're not welcome. We're already done. I pray for you all that the force be with you when we're finding the Pythagorean theorem in these space figures. I'll see you in class. Good night. Later.